Hi, let's look at our results. We had samples of size 50. This is a total of 163 samples that we had, and they were the sample proportions of, so we were getting the proportion of blue M&Ms. Now, this makes up a sampling distribution because it's how our samples are distributed. Now, the question we posed is, where did our M&Ms come from? So let's see. Here's my normal model, and here is the normal model with 24% in the center. So here is where our data would be centered if the M&Ms came from New Jersey factory. So now let's see if the M&Ms came from the Cleveland, Tennessee factory. Then let me scoot this so it's right centered. It's 20. Here's the normal model. I have it down here lined up with 20% in the middle. And voila, there we have it. So that is our real data, our 163 samples from yesterday. And there is where I think we can safely say that our M&Ms came from. It looks like we've got Cleveland, Tennessee M&Ms, and sure enough, on the back of the package, it said CLV, and so they did come from Cleveland, Tennessee, I can tell you that. All right, so we had our samples show us that they centered around the true proportion, the population proportion, okay? Now, here's just some other interesting tidbits of information. Now, this is theoretically what should happen if they came from Tennessee. Then they would have been centered at 0.24 with the standard deviation of 0.06. Now, here's what we actually had for our 163 samples. I put it in the calculator, all 163 samples. And so our average of all of our p hats. So it averaged all the p hats, and look at that, average 0.1975. So pretty darn close to 20% with this standard deviation 0.0616. So right where theoretically we would expect it to be. Now, look at these two different sets of data here. On the left, if our M&Ms came from New Jersey factory and I centered it at 24%. So that means if I had this little thing here moved to where it was centered at 24%, then I'm going to tell you how many outliers I would have had. Now, you remember outliers are the ones outside of 2 standard deviations. So see here, I can see here is this 2 standard deviations line right here. Okay, I can put that in there and let you see. So there is the 2 standard deviations line there and here. Okay, so look at all of these outliers that we would have had. Quite a few. In fact, I think I counted them and there were 14. So that was right at about 8.5%, between 8.5% and 9% of our samples would have been outliers that we would have gotten. And now also, let's see what would have happened if our data is centered at 20%. We actually would have also had some outliers. Here's the 2 standard. Oops. Here is the 2 standard deviation line for if they came from Tennessee, here and here. So we would actually had one sample here, one upper sample that was at 34%, and then 3 lower ones. There were 2 of them that had 4%. Those people only had 2 blue M&Ms, poor little 2 blue M&Ms, and one person had 6% M&Ms. Okay, so 3 M&Ms in their 50. Okay, so here is what that looks like. You know how within 1 standard deviation, we're supposed to have 68% of our data, and 2 standard deviations is 95% of our data? Well, here is how it fell. If we had it from New Jersey, 65% was in 1 standard deviation, 91% was within 2. So not quite good enough for the normal model. Now, if we say our data came from the Cleveland, Tennessee factory, which it did, that's where it came from, then look, we would have actually had a little bit better ranking than the normal model. 73% fell within one standard deviation, and 97.5% fell within two standard deviations. We had 2.5% lower, three lower and one upper outlier. Okay, so there is the summary for our proportions of blue M&Ms and the mystery of where did our M&Ms come from. So just remember that our sampling distribution is that the samples distributed, and they will center where that true population data is really centered. All right, I hope that was a fun little lab for you.